Hi, welcome to this video on composite perimeter and area. So a composite figure is a two-dimensional figure that cannot just be named as a single shape. So if I look at this shape that's given here in example 1, it says a L-shaped floor plan. This L-shaped floor plan isn't a rectangle or a square or a parallelogram or something to that. It's composed of, composite meaning composed of, more than one geometric figure because since it's concave. So what I can do is I can see this L-shaped floor plan as, rather than it just being a 1, 2, 3, 4, 5, 6, so a concave hexagon, instead I'm going to see this as two rectangles put together. And by doing that, I can easily find the area of it. So I'm going to start with area, and I'm going to break this up, and if I do, I can see that this right here, this rectangle, I have the dimensions conveniently put here for me, and I can find the area by doing the length times the width of this rectangle. And then over here though, this little rectangle, I know that this is 3, but I know this piece right here is not 5.2. But instead it would be the part of the 5.2 with the 3 taken out. So I needed to subtract 5.2 minus 3 to find this side here, which would be 2.2 meters. So I can also find the length and width of this rectangle now. So then what I'm going to do to find the area is I'm going to do the area of the big rectangle, 3 times 4.5. And the area of the smaller rectangle, which is 3 times 2.2, and I'm going to add them together. So there you go, I have 20.1 square meters in area. Now, to find the perimeter, then I'm going to, let me get rid of all this stuff here. To find the perimeter, I'm going to have to add the sides. Well, I see this side is 3, and this side is 4.5, and this side is 5.2, and this side is 3. So if I start listing out my side length, starting with the top there, 3 plus 4.5 plus 5.2 plus 3, those are the ones that are given, but I have to remember that this is also part of the shape, and so is this. So I need to also add this side and this side. Well, how long is this side? If you remember before, when we find the area, we realize that this is the same distance as this. So I already, out of this 5.2, I'm going to subtract that 3 away, and this is also going to be 2.2 up here. That's 2.2. But I need to do the same thing with this side. So this 4.5 meters is the same distance from here to here. That makes, if this is 3, I subtract and get this side here is 1.5. So now I need to know that I add plus 2.2 plus 1.5, and I should have 1, 2, 3, 4, 5, 6 dimensions, and I do have 6 dimensions, so that's good. So I'm going to add them together, which is 19.4 meters. Now there's another strategy for finding perimeter and another strategy for finding area. So I'm going to use that different strategy with number 1 here, and this wouldn't work. This wouldn't be the best strategy for every situation, but number 1 is a good example of where you could use this. So let's instead think of this, rather than thinking of this as 2 shapes, let's imagine that we took the longest dimensions here and created one big shape. So what would the large shape be here if we were able to take this side length here and push it all the way over and push this one all the way down and close up this hole? So what you're going to find is, by finding that, that's actually going to be the same. The perimeter of this shape here, this L shape, is the same as the perimeter of the whole shape that we could create. So since this is 6 and this is 6, that means over here would also be 6. And since this is 4 and this is 3, that means the long side here is actually 7 meters. and I would 3 plus 4 together would be 7. So to find the perimeter, I could do 6 plus 7 plus 6 plus 7. Now that works on shapes like number 1 or the first example 1 or the number 3 down here. That wouldn't work as well for 2 or 4. Will kind of work for 4, but not so great for 2. So anyway, so then the perimeter would be 26 meters. So that's a different way of finding perimeter. Going along the same lines, I can also find area in this way, and imagine this big piece here. Sorry that I exchanged my red was area before, but now it's, anyway, it doesn't matter. So I can find the area here of this large rectangle, which would be 7 times 6. And then instead of adding things, I'm actually going to be subtracting, because I'm going to subtract away. I'm going to take away this little piece, cut that out. So that would mean that I'm cutting out a rectangular piece that is 3 by 4. And how do I get the 4? Because if this whole side is 6, then I take away this 2. 6 minus 2 is 4. So this little piece here is 4. So that means I'm going to subtract away. I'm going to cut out this white area, which is 4 times 3. So that would be 30. Because 42 minus 12 is 30. So there's 2 ways of finding composite area. One is to break it up into pieces and add those pieces together. The other one is to make one big rectangle and subtract off the part that's cut out. Again, that strategy would work really well with number 3. It would not work as well. I mean, you could actually use that with number 2, and you could kind of make a big shape here, but then you're subtracting off 2 pieces, and I think that would be a worse strategy than just adding. And you could do that with number 4, but again, you'd have to subtract off 2 pieces, so it would be better in number 4 just to add the 2 areas together. So you kind of have to look at each one and see what's best.